we'll now look at the case of a free fall of a body. Here we are considering the various objects. When a body is thrown from certain height, you are taking the initial velocity of the body as 0 because it is freely falling. That means it is dropped from certain height. In this case, let us consider there are two bodies which are dropped from certain height. One is a stone, the other one is a feather. And whenever it is dropped from certain height, both of them will have an initial velocity 0. If at all there is a presence of g, then they will be attracted towards the surface. There will be a gravitational pull. But if at all there is no gravity, that means in the absence of g, in the absence of gravitational pull, then what happens? Both the stone and feather will behave in the similar fashion and they'll have the random motion. They are not under the influence of gravity. Now, if at all the gravity is present in the sense obviously atmosphere is also present because atmospheric particles are near the surface because of the gravitational pull. So, whenever gravity is present, of course the atmosphere is present. In case of the gravitational pull, here force acting on the body is a product of mass and acceleration. Here acceleration is replaced by g because the acceleration attained by the body is due to the gravitational influence. Here g acting on both the bodies are same, both the stone and feather. G is same, but the stone is heavier than the feather. That is the reason what is happening here. The force with which the stone is pulled will be definitely more because F also depends upon the mass of the body. If at all you calculate F is equal to mg, here F is equal to mg value is more for the stone compared to the feather. That is the reason there will be a more gravitational pull acting on the stone compared to the feather. Therefore, there can be a time difference on reaching the ground. So, stone reaches first whereas this reaches late. And here falling time also depends upon the shape because if at all you have the more surface area, there will be a more upward force acting on that which resists its motion. Just like here, in case of the feather, if its surface area is less, it experiences less frictional force, whereas here it experiences the more upward force. Because of that also the falling time depends. Of course, the falling time depends means the acceleration vary, the net acceleration vary. That means it also depends upon the falling time, the accelerations. These things depend upon the shape of the bodies also. So that is one more point to remember. Overall, whenever the bodies are moving towards the ground, it is due to the gravitational attraction, and that gravitational attractive force is given by the product of mass and acceleration due to gravity. That we have studied earlier also in equations of motion. That means whenever we are writing the acceleration concept in equations of motion under the influence of gravity, that A is replaced by G. That means acceleration is replaced by acceleration due to gravity part. In this case, F is equal to ma is replaced by F is equal to mg. Now, what does it mean by acceleration due to gravity? That is what we are to learn. So, acceleration due to gravity. So, it is denoted by a small letter g, and definition wise, the acceleration possessed by a body due to the gravitational pull is called as acceleration due to gravity. So, here the definition we have given, defined as the acceleration possessed by a body due to gravitational pull, and this value vary from planet to planet and body to body, because for ground, for the earth surface, the acceleration due to gravity is approximately 9.8 meter per second square. Of course, this value also vary from place to place. So, planet to planet it will vary, and on the planet also depending upon the positioning of the body. So, it is varying. So, G value varies from planet to planet and also from place to place. whereas capital G, what we have seen earlier, is not varying, it is universal constant. That means everywhere its value is going to be 6.67 into 10 power minus 11. That's a universal gravitational constant. And here we are studying about the small g, that is acceleration due to gravity, and acceleration due to gravity is changing from place to place and planet to planet. So as an example, we can see few cases over here. G value decreases as we go to heights. That means if at all you are considering a body present on the ground, its G value is something over here, G value is something here. When you are moving to the heights, the G value is changing. So this G dash value is less than G. That means as you are going to the heights, the acceleration possessed by the body at this place is more compared to this, because as you are going to the heights, G value is decreasing. Similarly, when you are moving to the depths also, G value is decreasing. That is G double dash is also less than G. And for these, there are certain calculations that we are going to look at in higher classes. Here you need to remember few points, that is when you are going to the heights, G value decreases. When you are going to the depths, G value decreases. And when you are moving from the equator to pole. So for example, if you take the Earth's surface like this, it is nearly sphere, not exactly sphere, nearly sphere. This is the equator, equatorial point, and these are the poles. Here it is flattened to certain extent. So at the poles, this is the north pole, this is the south pole, and this is the equator. So when you look at the poles, the G value is more, at the equator G value is less. That means when you are moving from equator to the poles, G value increases. That means it is going to be 9.81 something at the poles and 9.79 or something is at the equator. Likewise, the G value is varying from place to place also. So here you need to remember one point, G value, capital G and small g, there are variations that we will be looking in the next class, that is next video. And here you need to remember capital G is a constant, small g is a variable, and G is nothing but an acceleration possessed by a body due to the influence of gravity. So these are the points you need to remember before going for the derivation of other concepts of this particular chapter. Now look at the case here. Whenever we are calculating the G value at the equator and G value at the poles, G value at the equator is somewhat less than the G value at the poles. That means as you are moving from equator to the poles, the G value is decreasing, which means the small g value, acceleration due to gravity value, is varying from place to place. As in the first figure, when you are going to the heights, G value is decreasing. Similarly, when you are going to the depth also, G value decreasing. When you are moving from equator to the pole, the G value is decreasing. Likewise, there are some equations related to finding these G values that we will be looking into higher classes. But as and now, you need to remember G value vary depending upon the position of the body. That means whether it is on the surface or at a height or at a depth, depending upon its positioning, the G value is changing. So small g value is a variable, capital G value is a constant, and these differences we will be looking into the next video.